Good morning, everyone, and welcome to Checkpoint's Unified Cloud Native Security session. I'm Matt Irvine, and today I'm joined by my colleague Stuart Green. This morning's session will be going over a brief overview of Checkpoint, if you haven't heard of us, our relationship with Microsoft, especially around Azure, our approach to securing public cloud and the solutions we provide in this space. Stuart will be then running through the platform and showing you exactly how our tooling works and how it relates to some of the specific technologies in the cloud space. Checkpoint is a leader in cybersecurity with over 100,000 customers, trusted by the Fortune 500, have a global reach of over 88 countries with 6,200 partners, and been delivering solutions for our customers for the last 27 years. We're also recognized by the key market research organizations as a leader in cybersecurity. So what is cloud native security? Well, for us, it's about achieving continuous governance, visibility, and prevention across cloud workloads network that change all the time. We're a long-term partner of Microsoft and are currently their #1 independent software vendor, as well as their #1 security co-sell partner worldwide. As well as the commercial relationship, we're also one of the first vendors to appear on Azure Stack and are currently embedded with its Security Center and Sentinel. We've also won awards at a technical level for our integration with the Azure product set. In order to do this, security needs to be everywhere. Network and security threat prevention needs to work seamlessly between data center and cloud, sharing policies and configurations. Security posture management needs to be able to assess and remediate vulnerabilities in all cloud environments, workloads, and asset types. Application security needs to detect and prevent application layer attacks against APIs, workloads, and microservices. Threat analysts and threat hunting needs to be able to be done in real time with visibility across all workloads. So to protect against those needs and more, we've created our CloudGuard portfolio of products. From the bottom up, we've got IaaS, threat prevention and network security, which is designed to work on most major public and private cloud environments. We've also got Connect and Edge, securing SD-WAN environments and providing SASE solutions. At the top of the screen, we've got our SaaS platform, which secures cloud email and SaaS platforms like Salesforce and OneDrive. But today we'll mainly be focused on the highlighted sections in green. That's cloud security posture management, our container and serverless security, the ability to embed into CI/CD tools, and also the logic element of our portfolio that is detection and response. So coming up in Stuart's demonstration, you'll see how the platform provides visibility into workloads, security policies, regions, and accounts across AWS, Azure, GCP, and Kubernetes environments. You'll also see how the platform continuously enforces regulatory compliance like NIST 27001, GDPR, and several others, including best practice, and how you can apply your own flexible rule set called GSL into these standards. We'll also see it's consolidated and brings everything into one place against one rule set rather than having separate rule sets for things like Kubernetes environments or Terraform templates. We'll also show you how we provide active protection and remediation against unauthorized changes and vulnerabilities. To help developers embed security into the build phase, workload protection function can scan code, images, and deployment templates such as Terraform for embedded threats and misconfiguration. While in the runtime, the platform uses AI and machine learning to automatically adapt profiles to application changes. Both of these elements combined enable our clients to enforce guardrails from CI/CD through to production. The final area we'll cover is intelligence and threat hunting. This part of the platform provides security analysts with visual representation of VPC flow logs, cloud logs, asset configuration and vulnerability data from Checkpoint's Threat Cloud. The information is correlated and will enable analysts to quickly and easily investigate alerts, policy violations, and anomalies. As you can see, there are a number of areas our CloudGuard platform can address. Our goal is to provide clients with a unified set of tools that embed within the automated process, provide a single source of security management across multiple cloud environments. And with that, I will hand over to Stuart so you can see for yourself how the platform works.
Hi there, thank you for joining. My name is Stuart Green and I'm one of the cloud security architects working for Checkpoint covering the UK and Ireland, working with our channel partners and our end customers, helping them with cloud projects, whether it's cloud native projects or our CloudGuard IS product. Happy to help out with any opportunities or challenges that you might be having. So what we're going to look at now is the experience that you have when you're using the CloudGuard platform. So Matt's covered some of the areas that we look to address and some of the security concerns and visibility issues that customers have when they're using public cloud. This is our CloudGuard platform, previously known as Dome 9, in case you're wondering why the different name. What you see here is one of the many dashboards that you can configure when you first log into the product, and you get an overview of what's going on in your cloud estate. Now, for some customers, they might not have ever logged into one of the public cloud platforms, be it the AWS console, the Azure portal, or the GCP console. So having all of your information presented in one space can be a real advantage, and it can be really useful to get a feel for what's going on in your public cloud accounts where otherwise you might have no idea. So being a SaaS service, all you have to do is integrate your accounts by providing us with the API keys, either read-write or read-only, and we can then pull out the metadata around all of the assets that you've got configured in your public cloud accounts. Assets being things such as you can see here. So you've got storage accounts, S3 buckets, EC2 instances, many different types of assets across the different public cloud platforms that we support. So with the dashboards, you get a simple and easy to digest snapshot of what's going on in your public cloud estate at any given time. If you've got different teams or different roles and functions within the business that are interested in different things, let's say you've got a very large public cloud deployment and you're looking for information about storage, or you've got a team that's looking at serverless, you can customize these dashboards to present whatever information you want. If you don't have anything in mind, when you first configure the product, what you get is this dashboard, which gives you a good overview of what's going on, and it will give you a number of highlights for anything which is high severity, things that you need to look at with a sense of urgency, plus some other useful information like a breakdown of the type of assets you've got in the account across the multiple platforms that we support. Now, one of the useful day-to-day features of CloudGuard is, because we use the metadata for a number of things in the platform that I'll get onto shortly, having access to all that metadata from all the services across all the platforms gives you a really useful tool for searching particular assets in the cloud accounts. So let's say, for example, somebody came to you and said, can you please give me the details for the FTP server? All you'd have to do is go to protected assets, type in the name, the IP address, or anything that you've got as a kind of snippet of information that you need to try and look into. So here I've looked for FTP, and what it's done is it's filtered all of the assets, all of the 7,000 odd assets and the 8,000 that we've got in our account, and it's drilled down to the ones that I'm interested in. From here, you can click on that, and that will take you to the real-time configuration of that particular asset. So you can see here we've got the public IP, we've got the private IP, DNS configuration, what subnet CIDR range it lives within, and then we've also got the security groups that are applied to it. Now this is another feature of the platform where you can manage and modify the security groups that are attached to assets without having to leave the CloudGuard platform. So each of the platforms have their own somewhat unique approach to managing basic security controls. So it's either network security groups in Azure, ACLs and security groups in AWS, or the tag-based firewall in GCP, all with slightly different workflows and slightly different effects on what the rules do to your traffic. Now with the CloudGuard platform, you can modify all of the security groups and all of the inbound and outbound access from a particular asset without leaving the tool. So you don't have to worry about learning where to configure these in AWS and Azure and GCP. You can do it all from one place. So for example here, you can see all of the security groups which are attached to this particular asset. If you want to modify that, you can click on attach, and you can choose from all of the security groups that exist that are relevant to attach to that particular object. If you don't want to attach a new security group, you can go to one of the security groups that already exist, and you can modify the rules again without having to leave the tool. Now, taking this slightly further, we offer an additional feature called tamper protection, whereby if you give us read-write access into your public cloud account via the API, we can enforce that CloudGuard is the only platform where users or engineers, architects, whoever it might be in your business, this is the only tool they can use to make changes to it. So anything that's made programmatically or through the native cloud consoles or portals, we can detect that and we can roll it back to the baseline that you've established using the CloudGuard tool. So if, for example, somebody was trying to open up a port on an EC2 instance that wasn't an allowed port as per your corporate policy, we would detect that and we would roll that back automatically and generate a notification for that. So there would only be a very short time period where that port was ever open accidentally, let's say. Now that's one of the smaller features of the platform. A lot of the power of the platform comes from the compliance engine. So with access to all of the metadata that we have about all of the assets in your public cloud accounts, this gives us a really strong position to be able to assess that metadata against a number of frameworks that we provide you out of the box. So you see there, for example, we've got GDPR, we have NIST, CIS, PCI, ISO, and even best practice frameworks. So if you're a business that are obliged to comply with GDPR or PCI, that's fine. You can choose one of those and run it out of the box. But similarly, if you don't know where to start and you're fairly new to public cloud, you could start with one of our best practice or one of our checkup frameworks, which are a bit lighter weight than some of the more heavily regulated frameworks like GDPR or CIS. So let's go, for example, let's have a look at GDPR. Let's say we've connected up our cloud accounts and we want to get a feel for how compliant or not we are towards GDPR. What we do is we find the rule set that we're interested in. So we'll go for GDPR. Each of the rule sets consists of a number of rules which are built using our own compliance language, GSL, governance specification language. I'll cover this shortly, but this is an easy to understand, natural language-ish language to construct compliance assessment of the assets in public cloud. Don't worry about that for now. We'll move on to that shortly. But you can see here we've got a collection of rules, and these assess all of the technical elements within the public cloud account and match that to the particular checks in the framework. So don't worry too much about what the rules are for now. All we have to worry about is whether or not we're compliant. So what we do is we choose our rule set, we click on run, then we choose where to run it. Now we can choose all of our accounts, and being a demo account, there's quite a lot in here. I'll focus on the one that I use for all of my demos, and we'll limit it to a particular region. Again, you can scan all the regions if you want to, but in the interest of not keeping people sitting there watching a spinning wheel to disappear, we will limit this to one of the smaller regions we've got. Then you can choose your VPC as well. Again, I'm going to scan all because there's not too much in this account. So we click on run, and in the background, this is initiating all of the API calls to pull in the metadata and the configuration information that it needs to run it through our compliance framework. So you can see here that completed fairly quickly. We've got a reasonable amount of assets in this particular account, and you can see you get a good visual breakdown of, in this example, how poorly compliant you are with GDPR. So you get an overall test score, you get a breakdown of rules by severity, high, medium, low, also a geographic distribution of where your assets are. So if you're a business that is sufficiently large, so you've got different teams that look after different geographies within the public cloud accounts, you can use this to break down the report into relevant sections for the relevant teams. Then you've got a breakdown of the type of entities which were assessed as well. Most importantly, though, you've got the findings that we generate. So each of these findings are where we found one or more assets that don't comply with the technical checks that we've enforced through the rule set. So some of these are quite complicated, some of them are quite easy to understand. S3 buckets should use SSL. That's a fairly easy one to understand. S3 buckets outside of Europe, that's another easy one. If we drill into this one, we can see that what it's checking is that the S3 buckets should have a region in this particular list. Any that aren't within that particular region will be highlighted as failures. If you decide that as a business that particular rule doesn't apply to you, we've got a very granular way of adding exceptions. You can exclude the rule, you can exclude it by the account, or the individual entity, or a combination of all three if you wish. Now, CloudGuard is a platform which is designed to be accessible to all of our customers, regardless of how experienced they are in public cloud. So for example, we typically have conversations with people who are fairly new to public cloud, people who have been running public cloud for a while, and people who have done nothing but public cloud since their business has started. We have different options for consuming these compliance policies depending on where you are in your cloud experience. So if you're new to public cloud and you just want to get a feel for what's going on in cloud and what cloud means to you and your business, but more importantly, how compliant you are towards some of these rule sets and these frameworks. In that case, What we've done here is perfectly adequate. You log in, you choose the compliance rule set that you want to assess against, click on run, and wait for the report, and that's great. To take that a step further, you can schedule it. So you get a report of what's changed and what's good and what's bad every week, let's say. That's fine, and that's kind of the traditional way of running this type of oversight, visibility, and reporting tool, in that when you want to have a report, you get the report delivered and you get an email that says, here's what's good and here's what's bad. Now, the people that want to take that a step further are the ones that have been in cloud for a while and they're familiar with the environments, and they don't want to be logging into a tool like this every week, every day, every month, whenever the period might be that you want the report, clicking the button and getting the results. To take this a step further, what we do is we enable what we call continuous compliance. And this gives you, as the name implies, a continual compliance policy assessed against your cloud assets. Now, what that does is that couples one of the rule sets, or many rule sets, doesn't really matter, we can support one or we can support many, and we couple that with a notification policy. That might be a scheduled email, or it might be something more immediate. Now, on the immediate side, we can support emails, and that's fine. You can have an email alert whenever something bad is detected in your cloud account, or we can support API calls out of the platform to achieve more interesting automated responses to things that are outside of your corporate baseline. Now, we have something called CloudBots, which are a collection of open source Python scripts that are available on our Checkpoint Dome 9 GitHub page. You're welcome to take those, use them as they are, or modify them, or even build your own. What happens is, in continuous compliance mode, you have these rule sets running on a scheduled basis. So if anything changes outside of what you've established to be your corporate standard, any changes are detected, and the output of that change that's non-compliant is sent as an API call. Now, that might be sent to a cloud bot. It could be to an ITSM solution, something like ServiceNow or another help desk tool. And that could automatically create a ticket. It could automatically send a message to Slack. It could automatically fix the problem that we found. And this is what CloudBots aim to do. So we've got CloudBots for achieving common tasks that people want automated. Things like making sure you've got a particular security group applied to particular assets in a particular account with a particular tag. You can make them as simple or as complex as you want, and you can chain multiple actions together. Essentially, it's an API call out of the platform into whatever you're willing to program. So all written in Python, at least that's what we provide the CloudBots in. If you want to use a different language, completely welcome to do that. And it gives you the possibility to automate your compliance rather than having to go with the approach of logging in, clicking it, finding what's going wrong or what's not compliant in your account, taking a list of actions and remediating them automatically one by one. This gives you the possibility to automate a lot of the mundane and the boring tasks in your environment. That said, if automation isn't in your plans and it's not something you've got the appetite for, you don't have to do that, and you can stick with the more traditional approach and then just schedule things like email notifications or notifications into your collaboration tool of choice. The next part that we'll have a look at is something that might be a little bit more familiar feeling if you are kind of based on the traditional networking side of things, and this is a tool called Clarity. Clarity aims to give you a visualization of the level of risk and exposure that you have of your assets within your cloud virtual networks. So at a very high level, you can see here we've got various relationships and links between our VPCs, our AWS flavored virtual networks. What we'll do is, again, we'll focus on our demo environment that we have set up. You can see here we've got a number of different environments. And we get two different options. We've got security group and asset. We'll start with security group. Now, what this shows you is the level of exposure that each of these security groups has to the internet. Now, if I just turn this grouping off, I'll show you a little bit more clearly. What you have is 5 different columns. On the left-hand side, we've got external and things which exist either on the internet or as a part of a distributed architecture. Let's say you've got something running in AWS or Azure, and you're monitoring it from an external IP address, which might be your NOC or your network management station or some other part of the solution that needs access into that environment. The next column in is the DMZ, and this highlights any security group which is open on one or more port to the entire internet. So in this group, you'd expect to see things like web servers, load balancers, maybe file servers, maybe a database, depending on the architecture. Databases, I would expect in most situations, will be in the next column, which is partially open. This is where you've got an object open on one or more port again, but with a optional source filtering applied. So it's not accepting connections from 0.0.0.0/0. It's got a filter applied to it. So it's only accepting connections from a limited subset of IP addresses. Next, you've got internal assets, and these are things which exist on the private side of your public cloud network, so effectively your LAN bit in the public cloud. Now, this particular view gives you the level of exposure that your security groups have to the internet. Now, in AWS, you have the ability to attach multiple security groups to an asset, which means that you have to consider each of these security groups might be attached to a single asset. Now, with that in mind, it gives you kind of the situation where you've got to evaluate and consider what the effect is of having multiple security groups applied. We do that for you in this particular view, so we can go straight to Assets View, and this does that hard work for you. So again, if I turn off the grouping, you'll see here that we've taken into consideration all the security groups that might be applied to an asset, and based on whether you've got ports open to the entire internet or specific hosts or networks on the internet, we've rearranged that into this view again. So same type of layout. On the left hand side, we've got the external hosts and the external connections, being the internet and anything else that we've manually defined in our configuration. DMZ, we've got things like web server. We've got here some other bits that shouldn't be in there, namely the database server. So in this example, you can drill down into that and see that that database server really shouldn't be in the DMZ. That should probably be further back in the network. If you wanted to investigate it, all you've got to do is click on the name of that asset, and it will take you to the view that will show you which security groups are applied, what rules are within that security group, and why it might be offering all hosts on the internet to be able to connect to it. Once this is loaded up, we'll have a look into that. So you can see here we've got our scanning group, presumably to allow automated scans to happen in the demo environment. But then we've got this default security group here, which has been applied. So if we were just looking at the security group view, we would see that, okay, we've got this group applied to it, and then we've got a database server group, which only allows the right ports for MS SQL and SSH, but someone has either deliberately or mistakenly attached the default security group, which opens up SSH and port 80 to the entire internet, which is a problem in this particular instance. So it's a really useful tool for highlighting potential misconfigurations in a visual sense. Everything here is interactive, so if you wanted to see what the result would be of a particular host being compromised, all you've got to do is click on that particular asset, and it will highlight for you what can connect to it and what it can connect to. So you can see here, if somebody managed to compromise that database server, they would then have access into the internal network, and they could pivot from that asset onto numerous hosts with varying levels of access. And you can do that with any number of hosts. You can click through and see what would happen if they access host A, host B, host C, and what the resultant access that an attacker might get in that particular scenario. This works across all of the cloud platforms that we support. So I'm showing you AWS here, but it's equally as applicable to Azure, minus the separate views for security groups and assets. The next part that we'll look at is serverless security. So for AWS and currently in early availability for Azure, we have the ability to assess your serverless functions. Now, we have two methods of doing this. The first method is a static analysis of the code that your Lambda function or your Azure function is comprised of. Now with that, we can give you a number of findings. One of them is we give you a posture explorer, and we show you how your Lambda function or your serverless function is connected in your cloud environment. So in this particular example, we have an AWS Lambda function, and on the public side, it's connected to via an API gateway. On the internal side, so within the AWS cloud, we can see that it's connecting to S3, IAM, CloudWatch Logs, DynamoDB, and CloudFormation. All of this is assessed by looking at the code. So looking through the Python, the Node, the Java, it doesn't really matter what it is, we can determine what it's trying to connect to at an API level within the AWS environment. If there's anything in there that you find which is not desired or not correct, you can go off and fix that in the code, or you can use the workload firewall to prevent that in real time and block it at a software level. I'll move on to that shortly. On the static analysis side of things, we have the ability to assess for a couple of other things too. One of them is to pick up on any vulnerable dependencies that might be in use within that particular Lambda function. So if in this example we're using Node.js as a Lambda runtime, if we had any vulnerable packages in there sort of called in through npm, we could highlight that and we can alert you that there is a potential vulnerability in a particular Lambda function. All of that's reported through the alerting and the notification engine. So if I click over to alerts and findings, you can see here that this particular function, we have got a vulnerable dependency, and we've highlighted the specific CVE and what the vulnerability description is as well. So if you wanted to assess whether that was applicable to your environment, let's say it wasn't a high or critical finding, you could determine the level of risk yourself and say whether or not you wanted to leave it or fix it. We also have the ability to pick up on hard-coded credentials through the static analysis. So by looking at the code, we can identify if your developers have deliberately or mistakenly left credentials like your AWS client ID and secret keys in the Lambda function itself, which is poor practice, and there are better ways of managing secrets. If we do detect that, we can tell you which file it's in and which line of code it's in, so your developers can go off and fix that very quickly and very easily without too much scouting around. The next part that we've got for the static analysis is the ability to assess whether your IAM policies are giving too much access to a particular Lambda function. So for example, this is a demo Lambda function that we use for a couple of different demos, and it is deliberately designed to be vulnerable and overly provisioned in terms of IAM roles. Now what this function has, you can see here, we've detected that it has access to all S3 operations and resources within the account. So basically, if it's an S3 bucket, this Lambda function has access to it, read, write, delete, no matter what that bucket is within the account. Now looking at the code of that Lambda function, we've determined actually all it ever does is put objects, so it's used to store things in an S3 bucket. Therefore, the IAM policy that's applied is overly permissive. And as part of that static analysis, we're able to generate a more restrictive IAM policy for you that you can cut and paste from here, apply it in the IAM module of AWS, and harden that particular role for that particular service. You can see in here though, we've picked up on all of the things that we've got that we found from the Posture Explorer, so all of the different services that we picked up as accessing. We found problems with all of those, and it's got recommendations for each of those. So not all of them are as open as the S3 access, but they are still overly permissive in terms of what the function needs to do. So for that, you can take each of the fixes individually, or you can take all of them combined together into one policy, cut and paste this, and address all of the overly permissive roles in one action. All you've got to do is copy and paste that out as an IAM policy, apply it to your Lambda function, and that will remediate all of the problems with IAM when it comes to accessing things that it potentially doesn't need within the account. Now that's the static analysis side of things. We've also got a real-time protection that we called FSP, Function Self-Protection. This gives you a software WAF or a software workload firewall of sorts, and this gets deployed currently in AWS as a Lambda layer, and it gives you protection against OWASP top 10 style of attacks, so things like SQL injection, command injection, cross-site scripting, or other type of input validation attacks. And again, you don't have to specify these manually. All you have to do is enable the module, and you can optionally have it in detect only mode or full protection mode, where it will actively block those particular connections if it finds something bad with the payload of that particular input. So these are the static findings. If I scroll down a little bit, you'll see some examples of various attacks that we've picked up and prevented for this particular Lambda function. So we've got code injection attacks. It will give you a description of what that particular attack method is and what part of the code it was where we detected that particular attack. So again, if your developers or your architects, engineers, whoever it is in your organization want to go off and fix that particular problem, they know where to look. It's not just a case of we found something bad, go find it and fix it. We can direct you to which function it is and which part of the code is vulnerable to that particular attack. If you don't want to fix it, or you don't have time, or it's not within your remit to fix, you don't have to worry about it immediately. The FSP protection will take care of it for you. Obviously, as more of a long-term goal, it's going to be better if you do fix that vulnerability, but it's something you're not going to be exposed to. This module will protect you against that type of attack. Again, all of this is fed into the same compliance and notification system. So if you do detect something like this, you can send an email notification out, or you can generate an API call that goes out to maybe an external scanning tool, or to a help desk tool, or to send someone a voice call or a text message out of hours to say we've detected something critical or high priority, you need to fix this as soon as possible, please log on and start fixing it, even if it's 2 o'clock in the morning, for example. Again, it's an API call. You can integrate it with pretty much whatever you like, so long as the receiving system is able to receive REST API calls. The next part that we will look at is a feature called logic. So what we've looked at so far in the posture management side of things is assessing your static configuration and what exists as metadata for EC2 instances, load balancers, security groups, etc. All of the assets that you've got, we're looking at the configuration metadata. So what exists and what is configured. What that doesn't show you is where you're getting connections from when it comes to your public assets in your cloud accounts, and also what your assets are connecting to. So this is based off of your network flow log and your API log activity, and it gives you 2 slightly different views but with the same sort of purpose, which is to visualize the activity within your cloud accounts. Now this is a view which looks similar to the Clarity module, which we've already looked at, but this is based on real log traffic, so things that have been witnessed or logs in your particular cloud accounts. This is our seam-like solution, and it gives you the ability to search for things that you want to investigate in your account in a threat hunting style, and also to run automated machine learning based rule sets to pick up things like anomalous behavior in your accounts, or things which are outside of the baseline that we've established based on the sample data that we have for your log profiles. Now, something else you might have spotted here is the skull and crossbones in the external column. If you're a traditional Checkpoint customer, you will be familiar with something called Threat Cloud. If you're not, Threat Cloud is our global intelligence database whereby any Checkpoint component acts as a sensor, and it takes intel from and contributes to the Threat Cloud database. So anything like an IP address which is distributing malware, or that we know is part of a particular threat actor based on automated analysis in our sandbox environment, or if our research team have found something, we've contributed that manually to Threat Cloud. All of that goes back to the database and benefits all of our customers worldwide. So what this represents here is any connections from one of those malicious sources that is either connecting to an asset in your cloud account or being connected to by something in your cloud account. Now, the first example is kind of commonplace on the internet, and it's fairly reasonable to expect probes and scans from things on the internet from malicious sources. That's not something immediately that you need to worry about. What does need a little bit more urgency, however, is if you've got an asset in your cloud account that is actively generating connections to a malicious destination. That might indicate something like a node in a botnet, something that's been compromised already and is sending probes back to its command and control server, waiting for the next instruction, or trying to exfil data from your environment. It could be something that's been compromised by a crypto miner and it's sending its progress report back to, again, its command and control server or its master. In that situation, anything going to a malicious destination is generally a red flag and something that you can use this intelligence for to start an investigation and look at what other connections it's generating, whether it's trying to probe other parts of your cloud architecture or if it's just talking to one host on the internet. These tools give you the ability to investigate that in a visual sense rather than having to trawl through text-based flow logs if you were using the native tools in the native cloud consoles. This is all on the network side of things. We also give you the possibility to investigate non-network attached services and assets. So things like Lambda or IAM or anything which isn't directly attached to a VPC. And this works currently for AWS based on CloudTrail logs, and it allows you to perform the same type of investigation but using non-flow log based data. So this is again from CloudTrail and gives you the capability to search for services which are trying to elevate their privileges through IAM, trying to probe other components and see what their IAM policies allow them to do. It gives you a more rounded visibility of what's going on in your account, because without this, if you were relying on looking at the network activity logs, you'd be completely blind to the API side of things, where you might have a fairly substantial serverless architecture which doesn't necessarily generate flow logs. So having both views is important to get as full of visibility as you possibly can in your cloud accounts. Now, appreciate this has been a fairly quick tour of the CloudGuard platform. I would encourage you, if this is something interesting and something which you have a need for in your particular cloud account, reach out to Bytes. Bytes are offering a cloud security snapshot, which is powered by the CloudGuard platform, whereby they will onboard you into the environment for 30 days, give you access to it, let you have a look around, get a feel for what data you've got in your public cloud environment, and also generate some reports to see how compliant you are or not toward particular frameworks. And this is something they'll help you with. Like I say, reach out to Bytes if you're interested in that. If there's anything we can help with and you're watching this live, feel free to put a question in the QA panel and we'll get back to you. If you're watching this on demand, please get in touch with Bytes or your Checkpoint account manager or SE if you've got one, and we'll be happy to answer any questions. But thank you for stopping by and listening to us, and hopefully you found it useful.